Hello everybody, welcome back. Today we're starting 7.6 vertex form of a quadratic function. So far we've done two forms, the standard or general form, y equals ax squared plus bx plus c. And then in a couple of the previous lessons we looked at the factored form. Y is equal to a bracket x minus the first root, x minus the second root. We use R and S. Sometimes you'll see it as root 1, root 2. It doesn't make a difference. And then we're introducing a third form, which is called vertex form. And they use a H and K for the vertex. Sometimes you'll see this as P and Q. Again, it's just notation, nothing to worry about. Where H and K represent the vertex. So the vertex go in here, and we'll talk about the A value. And of course, the A value, if it's greater than 0, the parabola opens upward. If A is less than 0, the parabola opens downward. And of course, A, as we know, A, I'm going to add this one in here. I don't have it, but maybe I should. A cannot. A cannot equal 0, of course. Okay? Because if it equals 0, then it's no longer quadratic, right? It's that linear we talked about. All right? So let's look at the first question here. So what we're going to do is we're going to answer some of the questions. Example 1, sketch the graph of the following quadratic, and we're going to identify some of the questions at the beginning. So the first one says identify the direction which it opens upward. So if we look up here, if the A value is greater than 0, it opens upward. So the A value here is a 2. So we say since A is greater than 0, the parabola opens upward. Okay, that's all you need to do. Identify the coordinates of the vertex. So in this question, we're looking at the vertex coordinates. So if we have it, remember it's x minus h. So we have h and k, so it's plus k. So it's basically, if it's minus 3, then that means the point is actually 3, right? Okay? And then if it's minus 4, it's just how you see it. It's the sign in front, minus 4. Okay, so we got to be mindful of that when we're doing these. All right. Identify the x-intercepts of this function. So we'll do that after we graph that. I think that's something we'll do after the fact. Domain and range as well. Some of you may be able to get the range looking at it once we get the hang of this. But what we'll do is we'll graph this first. Okay. So I'll graph this using the, I'll do both. I'll use Desmos and our graphing technology. So what we're going to do is we'll plug this into our graphing calculator. We clear it. So second function plus 7, 1, 2. We'll clear your calculator and just hit enter. Hit y equals. Y equals, we'll put it in with 2 bracket x minus 3. Close your bracket, all squared. Minus 4. We'll hit graph, and there's your parabola. And what we want to do is we find the vertex in the. So we already labeled the vertex. That's a 3 and negative 4. I showed you that in vertex form. It's quite easy, but I'll show you how to do it on the graphing technology as well. So first, what we'll do is we'll find the x-intercepts. So we hit second function trace, which is calculate. Again, we've used this before. Remember, x-intercepts are going to be the zeros because y is equal to 0. Hit our 0. It's left down. It's up a little high. You can't see it here for some reason, so we just go down, right? Always look like that one there wasn't on my screen, so I knew the y value was too high. It was at 12, so I just got to bring it down by going to the right, left bound. Get close to the first x-intercept on the left. Go right until you're underneath. You can see that you're underneath when your y value is negative. Hit enter a second time, then it'll say guess. Hit enter for a third and final time, and boom, there we are. We have our x-intercept at 1.6 or 1.586, depending on how it rounded. If it doesn't say, go at least one place after the decimal. So I record that, then we do the second x-intercept. So again, it's second function second function trace, which is calculate. Go down to, you can press 2 directly, or you can press down and enter to get to 0. We're going to go to the second one now. So keep going to the right using your right cursor up here, right? Until you're close enough here. Enter, go over. Hit enter for a second. Third and final time, and it says guess, and you get 4.4 or 4.14. Okay? So what I'll do is I'll copy that one as well. I already did that on the graph, so I'll copy that. Okay, and there it is. All right, and there's your graph. So we have the two graphs that we need, okay, showing the x-intercepts on both. And we're going to graph this together in a minute. Sketch the function. We're going to sketch that graph in a second, and state the domain and range. So we have the two x-intercepts and a vertex so that we can sketch that graph right now. So I'm going to do that in Desmos with you. I'm going to sketch that graph. All right. So to sketch the graph, I'm going to put those equation in 2 bracket x minus 3 all squared minus 4. You'll see your graphs here. Okay. And I only took a portion of the graph as you folks needed. So I need a portion of the graph, so I'm going to take that now. And remember, there's our x-intercepts that we found on the graphing technology, and there's our vertex. Okay. So I'll take what I need from here. There we are. Okay. We'll take that and put that in our notes. I'll replace that graph with this graph here. Make it a little smaller. All right. And there's the graph as you would plot, right? So I just showed this how to find it on the graphing technology. There's our graph using, using Desmos. So remember, Desmos doesn't show the arrows going up. So up here, what you'll do is you'll add an arrow showing that it goes on forever. I'll do that with you in class, okay? So state the domain. So remember the domain. All right, so domain. Two ways to do it. So you can do the shorthand notation. You don't have to do the this is exact set long set notation. You can just do x to the n with the real numbers, right? Because it goes on forever left and right, because there are arrows, remember, it goes on forever left and right, even though you don't see it in the graph. Or you can do what's called interval notation. And we talked about this the other day, so it's negative, and open up your bracket, and it's what's called a round bracket, because you can't include infinity, and it goes from negative infinity to positive infinity. So that's another way to represent that. And then we'll do the range, okay? The range is the y values, right? So here, the lowest y value is -4, and it goes up. So we show that by saying y needs to be greater than or equal to -4, okay? Or, and we assume real numbers, we use it for the domain. Or we can say that square bracket -4. Square bracket means we include the -4 value, and that goes to positive infinity, which again has to be round bracket because we can't go any further. Okay, so either one's acceptable, whatever notation you like, I'm okay with. Again, it'll depend on your teacher or your professor, depending on where you go with this next. But that's all you need to do for that right there. So we've identified the parabola. It's greater than 0, so it opens upward. You can see that from when we graphed it. Identify the coordinates of the vertex. Remember, the vertex form, if it's in vertex form, you just look at here. It's whatever this number is. And if it's subtract, it's actually, you can think of it as the opposite. It's 3, and then whatever the number is in width, you take the -4 for the y value. Because it's minus h plus k, right? So it's kind of like it's plus a negative, so it's -4. All right, so we just got to be careful there. I showed you how to do it on the graphing technology. There's the two pictures you get when you do both zeros or x-intercepts. Graph the function we did in the domain and range. Okay. Let's look at example 2. This is determining the equation in vertex form. So first thing we do is we write the equation down in vertex form. So we have y equals a bracket x minus h squared equals that. And you could say the function too, but that's okay. Sometimes we'll say it as equation. And now what we'll do is we'll add in what we have. So we have the vertex. We look here, the vertex is 12 and 47.5. And we have another point which is going to come into play in a minute. So we know that we have a point x and y right here, 10 and 85.3, and we know that we have the vertex here. So the first thing we're doing is we're going to put the vertex in. That'll be step 1. So we'll take that, put the vertex in. H is 12, and K is 47.5. So now we want to solve for A, because we don't know A. A is what's called, it's actually what's called a vertical stretch, but again, we're not going to really talk about that until we get into Pre-Cal 11, if you take that. But that's what's called a vertical stretch for transformations. All right? Anywho, right now we just need to solve for A. But in order to solve for A, we're going to need to know X and Y. So you can pick any other coordinate on your graph. So we've picked, given the information on the graph, 10 and 85.3. So what we're going to do is we're going to take that equation in vertex form. We're going to substitute 85.3 in for Y, and we're going to substitute 10 in for X. So now we only have the one variable, and we can start to work this out. So the 85.3 is nothing yet. 10 subtract 12 would give us -2 squared. At the same time, what I might as well do is I might as well subtract the 47.5 from both sides, right? Because that's going to have to go anyway. So I might as well subtract the 47.5 from each side, just to be efficient. Again, if you want to do this one step at a time, you can. I'm doing it simultaneously, and that's all right as well. So now I'm going to clean this line up here. So the 47, subtract 47 is actually now eliminated, right? That's gone. Now I'm going to square the -2. I'm going to end up with 4, so that's just 4a. And then I'm going to subtract these two like I showed in this step. When I subtract the two of those, I get 37.8. Okay? Now the last thing I need to do with this is I need to divide each side by 4. So I divide this by 4, I divide this by 4. The 4's divide out, leaving you with a. That's what we're looking for. Alright, then we take 37.8 divided by 4. 4 divided by 4 is gone. Then we take that in our calculator. When we do that, we get 9.45. Okay, so there's the a value. So the function or equation, well, I'll say function. Function's a better word. We should start getting into that. The function that represents the parabola in, we'll do vertex form because that's what section we're doing in it, right? Is, so the function represented in vertex form is, you know, remember we get our vertex form. Your vertex, your function's always going to have x and y in it, so we need to replace a, h, and k, right? Your function always will have x and y in it. So the a value we obtained was 9.45. The h value was 12, and the k value was 47.5. Okay, so that's it for example 2. In the next video, what we'll do is we'll head to example number 3. So thanks for watching, and we'll talk again soon.